And we are back for our last example. All right, let me get my highlighter ready. The cost of 5 gallons of ice cream has a standard deviation of $7. Bad highlight job. Let's fix it. Yeah, okay. You guys know what I'm trying to do. Standard deviation of $7 with a mean of $39 during the summer. So let's go ahead and write that info down. We got a mean of 39, standard deviation of 7. Just be careful. Notice they're throwing in another number here. The cost of 5 gallons of ice cream. This 5 has no relevance to the problem. We don't need it to do any calculations. So just make sure you read problems carefully and don't just, pick out random numbers. Just read and it points out, standard deviation of, mean of, so on and so forth. Okay. What is the probability that the sample mean, once again, we got this wording, would differ from the true mean by more than $1.2? So it's a little different. Last problem was less than. Now we have more than. We'll talk about that in just a second. If a sample of 188 5-gallon pails is randomly selected. So my sample size is 188. N is equal to 188. Okay. Let's deal with this part highlighted in pink. So I'm going to draw my curve. I feel like drawing curves and seeing what you're looking at is very helpful. So just like the last problem, we're going to have to find two z-score values, two z-scores. But first you actually want to figure out their actual data values. So remember this mu, that's exactly in the middle, which is 39. Now we want a difference of 1.2. So we subtract and we add. So we do 39 minus 1.2 for this side, and over here, 39 plus 1.2. And we get two values. 37.8, and then 39 plus 1.2 is 40.2. Okay. Now, this one's different because, again, of the more than. So here we have differ by more than. So remember with the last problem, when we have differ by less than, we shaded the inside. We wanted to know the area between these 2 points. Well, this one's different. It says differ by more than. So like the difference between these data points and the mean is greater than 1.2. So when we have differ by more than, we are trying to find the areas like on the outside of those 2 points. So you're going to be shading in opposite directions. I'm just going to put, for down here, I'm going to put outside. Hopefully that makes a little bit more sense. We're not shading in between, we're kind of going outside of those 2 values, to the ends of the curves. Okay, let's write this into a probability statement. We want to know the probability that the sample mean is, there's 2 cases, less than 37.8 or if you want to get super mathematical, you can use that union symbol, or our sample mean is greater than 40.2. So there's 2 pieces that we got to figure out. All right, before we do anything else, we have to figure out the z-scores, do the transformation. So I'll do z1. So I'm going to call this Z1. On the first, over here will be, I'll go ahead and write this, Z1, and this will be Z2. Okay, so real quick, if you want to kind of, these problems can get really long. So sometimes it is helpful to be aware of certain like tricks that you can use to kind of make your life a little bit easier. So if you remember, if you come back up to, if you look at your third example, we were looking at a difference from the mean by less than 10 pounds was our number. And notice when we did the Z formulas, our top number was 10 in both cases, except one was negative and one was positive. Same thing is going to happen here. So like for my Z1 is my smaller number. It's on the negative side. So if you just kind of want to skip that first part of having to subtract X bar minus the population mean, which would be 37.8 minus 39, you're going to get negative 1.2. The negative of that number they told you to focus on for like the difference. Okay? But if that doesn't make any sense to you, don't worry about it. Just, do the equation as it is, and maybe you'll see the pattern and it'll click. But yeah, the more you practice, the better. The more you'll see the patterns that kind of emerge in these problems. So Z1 is equal to negative 1.2. That's the subtraction of those top numbers. And divided that by sigma, which is 7, over the square root of n, which is 188. All right. So I again recommend popping this into Desmos. And if you work all this out, you get negative 1.07. All right, second trick. To make our lives a little bit easier. So these points are the same distance from the mean. It's just on different sides. This one's 1.2 away, this one's 1.2 away. So my top number is going to be exactly the same. It's just going to be positive 1.2, and the bottom's going to be the same. And basically, we're going to get the same answer as Z1. It's just going to be positive. So really, if you want, you can skip all that work, and your Z2 is going to be positive 1.07. All right. But once again, if you're like not convinced, use the formula. Plug everything in. You will get the same exact answer. All right, so let's rewrite this. We want to figure out the probability that Z, because we transformed everything to Z's, is less than negative 1.07, or Z is greater than positive 1.07. Okay. So I did a problem like this in videos from chapter 8. I think section 8.4. 8.3 actually, where we had to find the areas in a graph or a distribution that looked like this, right? We were kind of shading the outsides. So to figure out the total area, we basically just add these individual areas. So we want to figure, it'll be the probability of Z being less than negative 1.07 plus the probability that Z is greater than positive 1.07. Right? We're going to add these two areas separately. This area to the left and then this area to the right. Okay, so I'm going to go ahead and do a little bit more simplification of this before we go to the Z table. So this first part, this Z is less than, that's area to the left. And that's what a Z table gives us. So I'm just going to leave this as is. But this second part is not to the left, right? This is to the right. And what's to the right? We have to do 1 minus the area to the left. So I'm gonna bracket this and rewrite this piece as 1 minus the probability that z is less than 1.07. Okay, so again, just to review, probability to the left, you want to leave that as is, but if it's to the right, we got to rewrite it, 1 minus the probability to the left. Okay, so check your z table. Let's see if we get the same answers. The probability that z is less than negative 1.07 should be 0.1423 plus, and then we have this 1, so plus 1, and then minus the probability that z is less than 1.07. Looking that up in the z table, you should get 0.8577. All right. And now just pop this into a calculator. You should get 0.2846. Okay. And that is our final answer. So the probability that if we, randomly select a sample of 188 5-gallon pails, the probability that the mean of that sample is either less than 37.8 or greater than 40.2 is 0.2846. Okay. So that is the 4th problem. And the homework in section 9.3 has a bunch of problems like this. And I'm pretty sure I covered one of each type. So you might have a less than, a greater than, a differ by less than, which means shade in between, and then a differ by greater than or more than, and that means we're kind of shading the outsides. All right. If you guys have questions, please let me know. You can always email me. Have a great day.